For more than 4,500 years, it has stood here, silent, immovable, defiant of time. Before empires had names, before scripture was written, before history learned how to remember itself. The sun rises over the Giza plateau just as it has since the age of the pharaohs. Sand glows gold, stone darkens, then burns with light. And standing at the center of it all, an impossible mountain shaped by human hands. The Great Pyramid of Giza. Built around 2550 BCE during Egypt's Old Kingdom for a king named Khufu, known to the Greeks as Cheops, a ruler whose reign lasted little more than 2 decades, yet whose monument would outlive nearly every civilization that followed. Once, the pyramid was not rough or broken. It was smooth, encased in polished white Tura limestone, reflecting sunlight so intensely it may have appeared to glow from miles away. At its peak sat a capstone, perhaps plated in gold or electrum, catching the first light of dawn. At 146 meters tall, it was the tallest man-made structure on Earth for nearly 4,000 years, until medieval cathedrals finally surpassed it. Its scale defies instinct. Roughly 2 to 2.5 million stone blocks, each weighing between 2 and 70 tons. More than 6 million tons of material, assembled with astonishing precision. Some joints so tight a blade cannot slide between them. No iron tools, no wheels for heavy transport, no modern machines. And yet, the pyramid is aligned to the cardinal directions with near-perfect accuracy. Its base is level to within centimeters across hundreds of meters. Its internal passages are angled with mathematical intent, not guesswork. This was not brute labor alone. It was planning, surveying, logistics. A state-level project requiring food supply chains, skilled crews, architects, priests, and administrators. So why was it built? Not as a tomb alone, but as a cosmic engine of rebirth. To the ancient Egyptians, the pyramid was a stairway to the sky, a resurrection machine. A place where the king's soul, his Ka and Ba, could reunite and ascend to join the imperishable stars. Khufu did not build for memory, he built for eternity. And yet, centuries of exploration, robbery, and study, its inner chambers remain enigmatic. Its construction methods still debated. New voids are still being discovered inside its stone core. What knowledge did its builders possess? How did an early Bronze Age civilization organize such an effort? And what does this monument reveal? Not about gods or aliens, but about the human mind, belief, and ambition. This is not a story of lost super technology. This is not a myth of visitors from the stars. This is the story of people. Of engineers who measured the earth and sky, of laborers who carved, hauled, and placed stone with discipline and pride, of priests who mapped eternity onto architecture, and of a king who believed his survival after death depended on precision, ritual, and stone. This is the story of the Great Pyramid, and its secrets are still watching the sunrise.
The Great Pyramid did not appear out of nowhere. It was not an accident of ambition, nor a single ruler's obsession carved in stone. It was the product of an entire worldview. We are in the Old Kingdom of Egypt, roughly 2686 to 2181 BCE, an age later remembered as the first golden era of Egyptian civilization. Power was centralized, borders were secure, and the Nile flooded with predictable generosity. For the first time in history, a state possessed the wealth, organization, and belief system capable of reshaping the landscape itself. At the center of this world stood the Pharaoh. He was not merely a king. He was not merely a god. He was the living bridge between the human and the divine. In life, the Pharaoh was Horus, the falcon god, protector of kingship, lord of the sky. In death, he would become Osiris, ruler of the afterlife, judge of the dead, and guarantor of rebirth. This transformation was not symbolic, it was essential. The Egyptians believed the universe was governed by Ma'at, truth, balance, order, and harmony. Floods arrived on time, stars followed fixed paths, society itself reflected cosmic design. If Ma'at collapsed, chaos, Isfet, would consume the world, and the Pharaoh was Ma'at's anchor. His survival after death ensured the sun would rise, the Nile would flood, and Egypt would endure. His failure would endanger all existence. Eternity was not personal, it was political, agricultural, cosmic. This belief shaped everything. Temples were aligned with celestial cycles. Art followed strict proportions, unchanged for centuries. Statues were carved not as portraits, but as eternal vessels, perfect, timeless, unaging. Even the human soul was understood as a complex system. The Ka, life force, the Ba, personality, the Akh, the transfigured spirit. For rebirth to occur, the body had to remain intact, names had to be spoken, rituals performed, and offerings maintained forever. And so, architecture became theology. The pyramid was not merely a tomb, it was a resurrection machine. Its shape echoed the Benben, the primeval mound that rose from the waters of chaos at creation. Its sloping sides formed a frozen ray of sunlight, a ramp for the king's soul to ascend into the heavens. Its interior passages aligned with stars associated with immortality, the imperishable northern constellations that never set. Every block placed was an act of faith, every measurement a ritual decision, every laborer participant in a sacred national project. To build a pyramid was to reenact creation itself. This was the Old Kingdom worldview, a universe ordered by gods, a state unified by belief, a king whose eternity was inseparable from the fate of the world. The Great Pyramid would be its most extreme expression, but the idea behind it was already ancient, powerful, and unquestioned.
Between roughly 2686 and 2181 BCE, Egypt embarked on the most ambitious building campaign the ancient world had ever seen. More than 70 pyramids rose along the Nile, from the desert edge at Saqqara to the limestone plateau of Giza. This was not a sudden burst of vanity. It was a centuries-long program of innovation, driven by belief, state power, and relentless experimentation. It began with a revolution in stone. Under King Djoser of the Third Dynasty, Egypt abandoned mud-brick tombs and dared to build eternity from limestone. His architect, Imhotep, stacked 6 mastabas into the step pyramid, the first monumental stone structure in history. It was not yet a true pyramid, but it changed everything. Stone could last forever. Kings could rise higher than ever imagined. What followed was a generation of trial and error. Early attempts collapsed or deformed. Angles were misjudged, foundations shifted, yet each failure taught a lesson. Builders refined quarrying methods, learned how to move heavier blocks, experimented with internal chambers, and, most critically, tested slopes that would not betray the structure over time.
This age of experimentation reached its peak under Sneferu, founder of the Fourth Dynasty and father of Khufu. No king built more and learned more than Sneferu. At Meidum, his first pyramid began as a step structure, later converted into a smooth-sided pyramid. The transformation failed catastrophically. Much of the outer casing collapsed, leaving the ruin seen today. But Egypt did not retreat. Instead, Sneferu tried again. At Dashur, engineers began the bent pyramid with bold ambition. Midway up, the angle suddenly changes, from steep to shallow, likely to prevent collapse after structural cracks appeared. The result is strange, even awkward, but invaluable, proof that ancient builders actively monitored stress and adapted in real time. Then came success. The Red Pyramid, also at Dashur, stands as Egypt's first true, stable, smooth-sided pyramid. Its lower angle distributes weight safely. Its chambers remain intact. Its design works. Here, the pyramid finally becomes what later generations would perfect. By the time Sneferu died, Egypt possessed something unprecedented: mastery of large-scale stone construction, proven geometric formulas, an experienced labor force, bureaucracies to supply food, tools, and manpower, a religious ideology that justified limitless effort. This was no longer experimentation, it was a system. When Khufu ascended the throne, he inherited not only royal authority, but the accumulated knowledge of nearly a century of architectural trial. The state knew how to quarry, transport, align, feed, house, and command tens of thousands of workers. Surveyors understood stars and cardinal directions. Engineers understood stress, load, and precision. The Great Pyramid would not be an accident. It would be the culmination of a pyramid boom, a national obsession refined by failure, perfected by persistence, and driven by the belief that stone could conquer death itself.
The Great Pyramid was not built in the desert by accident. It was built where water, land, and power converged. For ancient Egypt, the Nile was not merely a river, it was the engine of civilization. Every harvest, every city, every monument depended on its annual flood. And during the reign of Khufu, the Nile did not flow as it does today. Recent environmental and geological studies, combining sediment cores, satellite imagery, and paleohydrological modeling, have revealed that a major branch of the Nile once ran far closer to the Giza Plateau than the modern river. This now vanished waterway, often called the Khufu Channel, flowed along the desert's edge, directly beneath the plateau where the pyramids stand. Today it is invisible, buried beneath sand, silt, and modern development. But in the Fourth Dynasty, it was alive. This channel transformed everything. Limestone blocks quarried at Tura on the eastern bank could be loaded onto barges, floated across the river, and brought within a short distance of the construction zone. Granite from Aswan, more than 800 kilometers to the south, could travel downstream with the current, arriving at Giza not by miracle, but by hydrology. Water replaced brute force. Instead of dragging multi-ton stones across miles of desert, builders used seasonal flooding to their advantage. Canals, basins, and harbors were dug and maintained. At flood season, barges rode high. During low water, unloading zones remained accessible. The rhythm of construction followed the rhythm of the river. Around the pyramid arose an industrial landscape. Harbor facilities and docking basins, worker villages with bakeries, breweries, and granaries, administrative buildings recording rations and labor crews, causeways linking river ports to the pyramid base.
The pyramid complex was not isolated or mystical, it was embedded in infrastructure, a carefully planned system connecting quarries, river traffic, labor forces, and sacred architecture. This landscape also shaped symbolism. From the Nile's black soil rose life. From the desert's red land rose death and rebirth. The pyramid stood precisely at this boundary, where water met stone, where the living world touched eternity. Each block that arrived by river was not only cargo, but ritual movement, from fertile chaos into divine order. The Great Pyramid was not simply built beside the Nile, it was built because of it. Forget the image of endless lines of enslaved men beaten beneath the desert sun. That story belongs to legend, not to evidence. Archaeology tells a far more human story. At the foot of the Giza Plateau lie the remains of a planned workers' city, known today as Hayt el Ghurab. Excavated over decades, it reveals streets laid out with purpose, barracks capable of housing thousands, bakeries large enough to feed an army, breweries producing vast quantities of beer, and storage facilities stocked with grain, fish, and meat. These were not prisoners. They were state laborers, skilled and unskilled, organized, supplied, and honored. Analysis of animal bones shows workers consumed beef, sheep, and goat, an unusually rich diet in ancient Egypt. Beer, nutritious, fermented, and safer than raw water, was issued daily. Bread was baked in industrial quantities. This was fuel for bodies doing some of the hardest labor ever attempted by human hands. Medical evidence tells an even more striking story. Skeletons recovered from workers' cemeteries show healed fractures, amputations, and spinal injuries, proof that injured laborers were treated, not discarded. Some bones display signs of primitive but effective surgery and long-term care. These men were valuable. The state invested in keeping them alive. Labor was organized in rotating crews, often divided into teams like Friends of Khufu or Drunkards of Menkaure. Graffiti left deep inside the pyramid's hidden chambers records these crews, proudly, casually, like modern workers signing a finished project. Most workers were not permanent laborers, they were seasonal conscripts. When the Nile flooded each year, farmland vanished beneath water. Farmers could not work their fields. Instead, they were mobilized for royal projects, feeding themselves through state rations while serving the god-king. In return, they earned prestige, sustenance, and participation in a sacred national mission. This was corvée labor, a form of taxation paid not in silver but in time and strength. And it was sacred. To build the king's pyramid was to help sustain Ma'at, cosmic order itself. The pharaoh's successful resurrection ensured the Nile would flood, the sun would rise, and Egypt would endure. Every block placed was not just construction, it was ritual. The Great Pyramid was not built by fear. It was built by belief, organization, and a state capable of turning faith into stone. The Great Pyramid could not have been built just anywhere. Its location was as carefully chosen as its design. The Giza Plateau rests on a bedrock of Eocene limestone formed over 30 million years ago. This stone is dense, stable, and resistant to shifting, capable of bearing millions of tons without settling or collapse. Unlike softer Nile alluvium, which swells and erodes with water, Giza's limestone foundation offered permanence. Eternity demanded nothing less. This geological advantage mattered. Khufu's pyramid weighs over 6 million tons. A weaker foundation would have cracked, tilted, or failed within generations. At Giza, the bedrock rises close to the surface, allowing builders to anchor the monument directly into living stone. In some places, they even carved the pyramid's base into the natural rock itself, merging architecture with geology. Elevation was equally crucial. The plateau rises high above the Nile floodplain. Each year, the river surged outward, renewing fields, but threatening low-lying structures. Giza stood safely beyond the reach of floodwaters, ensuring the king's tomb would never be swallowed by the river that sustained his people. Yet Giza was not isolated. Across the river lay Memphis, Egypt's administrative and ceremonial capital during the Old Kingdom. From the summit of the pyramid, one could symbolically overlook the heart of royal power. The living king ruled from Memphis, the eternal king watched over it from Giza. This relationship was deliberate. Pyramids were not merely tombs, they were statements of authority, visible for kilometers. Approaching Memphis by river, travelers would see the pyramids rising on the western horizon, the land of the dead, announcing divine kingship in stone. Geography became propaganda. There was also sacred meaning. The west bank of the Nile was associated with death and rebirth, where the sun set each evening before journeying through the underworld. Building Khufu's pyramid on the western desert aligned his burial with the daily cycle of the sun god Ra, death, renewal, and eternal return. And finally, practicality. Nearby quarries supplied most of the pyramid's limestone blocks. A now lost branch of the Nile allowed stone, food, and labor to flow directly to the site. Giza was not just sacred, it was efficient. The plateau offered stone, height, symbolism, visibility, and access in one place. Giza was not chosen by chance. It was the only place where geology, ideology, and imperial power converged, a landscape worthy of eternity. The Great Pyramid is not only massive, it is precise. At its base, the pyramid forms an almost perfect square, each side measuring roughly 230.4 meters, with a difference between the longest and shortest sides of less than 20 centimeters. For a monument built over 4,500 years ago, this level of accuracy is staggering. Even more astonishing is its orientation. The pyramid's sides align with true north, south, east, and west to within a few arc minutes, an error of less than 0.05 degrees. No magnetic compass was used, no satellite guidance, yet the alignment rivals and in some cases surpasses that of modern constructions. This precision was not accidental. Egyptian surveyors, known as harpedonapti, rope stretchers, used cords, sighting tools, and stellar observations to establish cardinal directions. By tracking circumpolar stars, those that never set, they could mark true north with extraordinary consistency. The heavens became their measuring grid. The pyramid's proportions reveal the same discipline. Its original height was about 146.6 meters. Its half-base length was roughly 115.2 meters. When these values are compared, the slope of the pyramid, about 51.84 degrees, emerges naturally. This angle was not symbolic mysticism, it was structural logic, steep enough to stability, shallow enough to build safely. The ratio between the perimeter of the base and the height closely approximates 2 pi. Some have claimed this proves advanced knowledge of transcendental mathematics, but Egyptologists see something more grounded, the result of consistent unit systems, standardized slopes, seked, and practical geometry refined over generations. The builders worked in royal cubits, subdivided into palms and fingers. Using this system, the pyramid's dimensions resolve into elegant whole numbers, evidence of planning, not coincidence. There are no secret codes carved into the stone, no alien equations, no lost superscience. What exists instead is something far more impressive, a civilization that mastered measurement, repetition, and control. The Great Pyramid is geometry made monumental, not a mystery of magic, but a triumph of human intellect. To the ancient Egyptians, the pyramid was not merely architecture. It was cosmology rendered in stone. Its form echoed the Benben, the primordial mound that, according to creation myths, first rose from the waters of chaos at the beginning of time. From this mound, the sun god Ra emerged, bringing light, order, and life into the universe. Every pyramid was a monumental repetition of that first moment of creation. The pyramid's sloping sides were not random plains of stone. They mirrored sunlight itself, solidified rays descending from the heavens. In death, the king did not simply rest within the pyramid. He ascended it, transformed, climbing the luminous slopes to reunite with Ra and sail the sky in the solar bark. This belief shaped every detail. The pyramid stood on the western bank of the Nile, the land of the setting sun, symbolic realm of death and rebirth. Its temples and causeways were carefully aligned, guiding ritual movement from life to death, from earth to eternity. The valley temple received the king's body. The causeway carried it upward. The pyramid temple prepared it for divine transformation. Together, these structures formed a sacred journey in stone. The Giza Plateau itself became a cosmic map. The three Great Pyramids echoed patterns seen in the night sky. Scholars debate the exact stellar correspondences, but the intention is clear. The king's afterlife was written into the heavens. Carvings, texts, and alignment all reinforced the same message. The pharaoh was not meant to vanish. He was meant to become eternal. The pyramid did not just house the dead king. It activated his rebirth. Stone, light, landscape, and belief fused into a single system, a machine not for power, but for immortality.
The Great Pyramid was not built from a single source. It was assembled from the geology of an empire. Most of its immense bulk, over 2 million blocks, came from local limestone, quarried directly from the Giza Plateau itself. These stones were rough, practical, and structural. They formed the hidden body of the monument, unseen, uncelebrated, but essential. The pyramid, quite literally, rose from the land beneath it. But what the ancient world saw was something far more radiant. The outer casing stones were cut from the finest limestone at Tura on the eastern bank of the Nile. These blocks were pure white, dense, and polished to a mirror-like finish. When newly set, the pyramid did not appear golden or sandy. It gleamed. Sunlight reflected off its surface so intensely that ancient writers claimed it could be seen from miles away, a man-made mountain of light. This contrast was deliberate. The inner core was local and earthly. The outer skin was distant, refined, and luminous. And then there was granite. For the king's chamber, where the pharaoh's transformation was believed to reach its climax, builders chose red granite from Aswan, over 800 kilometers to the south. This stone was harder, heavier, and vastly more difficult to work than limestone. Each block weighed tens of tons. Transporting them was a feat of coordination on a national scale.
Granite was quarried in Aswan, shaped with stone tools, hauled to the Nile, floated north on barges during the annual inundation, dragged across causeways, and raised into the pyramid's core with precision measured in millimeters. This was not excess, it was symbolism. The most distant stone marked the most sacred space. The heart of the pyramid contained the farthest reach of royal power. From local bedrock to distant quarries, the pyramid unified Egypt itself, a monument not only built by the kingdom, but built from it. The Great Pyramid looks eternal, but its endurance is not mystical, it is material science. Modern petrographic analysis, microscopic examination of stone thin sections, has allowed scientists to study the pyramid's building materials at the crystal level. What they discovered is a story of deliberate selection and intelligent use of natural resources. The majority of the pyramid's core is built from Giza limestone, quarried directly from the plateau. Under magnification, this stone reveals fossilized marine organisms, tiny shells compressed over millions of years. These fossils are embedded in a calcite matrix that gives the stone high compressive strength. Compression is everything in a pyramid. Unlike beams or arches, pyramids distribute weight downward and outward. Every block presses into the one below it. The structure does not rely on tension, it relies on gravity, and gravity favors limestone. The stone's slight porosity also played a subtle role. Microscopic pores allowed minor stress redistribution and helped prevent catastrophic cracking under immense weight. For the outer casing, builders chose Tura limestone, a much finer-grained and denser stone. Its low porosity made it resistant to wind erosion. When polished, it reflected sunlight brilliantly while resisting moisture penetration. Durability was not accidental, it was geological strategy. Then there is granite. Granite from Aswan is composed of interlocking quartz, feldspar, and mica crystals. Quartz gives hardness, feldspar gives rigidity. Together, they create a stone capable of supporting enormous loads without deformation. This is why granite was reserved for the king's chamber and the massive relieving chambers above it, areas where structural stress was greatest. And what of the mortar? For centuries, people assumed mortar held the pyramid together like modern cement. It did not. The mortar used at Giza, made from gypsum, limestone dust, and water, was not structural glue, it was a leveling compound. The blocks themselves bear the load. The mortar's purpose was precision, it filled microscopic gaps between stones, compensating for irregularities in the quarry-cut surfaces. This allowed massive blocks, some weighing several tons, to sit flush against each other with astonishing tightness. In many joints, a blade cannot pass between stones. The builders were not relying on adhesive strength, they were engineering contact surfaces so exact that gravity became the binding force. Modern analysis has also shown that the mortar sometimes contains trace minerals and impurities that improved its setting behavior in Egypt's dry climate. It hardened quickly, stabilized the placement, and then became secondary once the block settled under weight. The pyramid stands not because it is glued together, but because every stone was shaped, placed, and seated with scientific understanding long before the word science existed. The durability of the Great Pyramid is not magic. It is geology, physics, and craftsmanship, working in silent harmony.
The cast stone debate. For centuries, the question seemed settled. The Great Pyramid was built from quarried stone, cut from the earth, transported, and placed by human hands. But in recent decades, a controversial theory emerged. Some researchers, most notably materials scientist Joseph Davidovits, proposed that a small number of pyramid blocks may not have been carved at all, but cast. According to this hypothesis, ancient builders crushed soft limestone into powder, mixed it with water and natural minerals, and poured the slurry into molds. The mixture would then harden into stone-like blocks, an early form of concrete, sometimes called a geopolymer. Under a microscope, certain samples from the pyramid appear to show unusual internal textures, air bubbles, microstructures, and mineral arrangements that some argue resemble artificial casting. If true, this would suggest that Egyptian engineers had developed a technique thousands of years ahead of its time. But most geologists remain cautious. Extensive field studies show clear quarry marks throughout the Giza Plateau. Blocks still sit half-finished in ancient quarries. Tool impressions from copper chisels remain visible. Transport ramps, worker graffiti, and logistics papyri all point toward traditional quarrying. Chemical analysis overwhelmingly matches the natural limestone formations of the Giza Plateau and nearby Tura quarries. If casting occurred at all, it was likely rare, experimental, or limited to specific small elements, not the pyramid's structural core. The overwhelming majority of evidence confirms that the pyramid was built the hard way: cut, moved, lifted, placed. What matters most is not speculation, but achievement. Not mystery, but mastery.
Debunking energy myths. In modern times, the Great Pyramid has inspired not only scientific study, but imagination. Some claim it was a power plant. Others say it generated electricity, focused cosmic energy, or served as a lost technological machine. But the evidence tells a different story. Limestone, the primary building material, is an electrical insulator. It does not conduct electricity. There are no wires, no metal circuits, no generators, no inscriptions describing energy production. Ancient Egyptian texts are extraordinarily detailed. They describe rituals, offerings, engineering, astronomy, and construction. Yet nowhere do they describe the pyramid as a machine. Its internal spaces are funerary, symbolic, ritual, not industrial. The pyramid's power was real, but it was not electrical. It was psychological, political, spiritual. It was designed to transform a mortal king, most famously Khufu, into an eternal god. The pyramid was not a generator of electricity, it was a generator of immortality. Its true function was to bridge two worlds, earth and sky, life and eternity, man and God.
How was it built? The numbers. The Great Pyramid of Giza was not built with a single miracle. It was built with millions of decisions, each stone placed with purpose, each action repeated again and again for decades. The numbers alone are staggering. More than 2 million stone blocks formed the pyramid's core, each weighing on average between 2 and 3 tons, the weight of a modern SUV. Some blocks, especially the granite beams above the king's chamber, weigh as much as 70 tons. Together, they form a structure containing over 6 million tons of material. Its original height reached 146.6 meters, equivalent to a modern 45-story building. And all of it was completed in roughly 20 to 30 years during the reign of the Pharaoh Khufu. This means workers had to quarry, transport, shape, and place roughly 250 blocks per day, every day, for decades. This was not merely construction. It was one of humanity's first mega-projects, a national effort involving thousands of laborers, engineers, administrators, priests, and planners. Behind every stone stood a system, a machine made of people, not powered by engines, but by organization.
Ramps and logistics. The greatest mystery was not cutting the stone, it was lifting it. How do you raise millions of tons higher and higher with no cranes? The answer lies in ramps. Many types of ramps have been proposed: straight ramps extending from the ground to the pyramid's face, zigzag ramps climbing along one side, spiral ramps wrapping around the exterior, and perhaps most intriguingly, internal ramps hidden within the pyramid itself, proposed by architect Jean-Pierre Houdin. Each theory solves part of the puzzle, but no single ramp explains everything. The most likely answer is a hybrid system. Early in construction, when the pyramid was still low, workers used massive straight external ramps. These ramps allowed heavy stones to be dragged upward with relative ease. As the pyramid grew taller, straight ramps would have become impossibly long and steep. At this stage, builders likely shifted to more efficient methods: spiral ramps wrapping around the structure, or internal ramps concealed within the pyramid's core. But ramps alone were not enough. The real secret was friction. Ancient tomb paintings show workers dragging enormous stone blocks on wooden sleds. In front of them, another worker pours water onto the sand. Modern experiments confirm why. Water reduces friction. It stiffens the sand, prevents the sled from sinking, and allows fewer workers to move greater weight. A simple innovation, but revolutionary. This was engineering born from observation, physics mastered through experience. Stone by stone, ramp by ramp, the pyramid rose, not through mystery, but through method, not through magic, but through human ingenuity.
Core construction. From the outside, the Great Pyramid appears to be a solid mountain of stone, an impenetrable mass, a monument built to endure forever. But inside, it is something far more sophisticated. The pyramid is not solid. It is a carefully organized internal system of chambers, corridors, structural layers, and hidden spaces, an engineered skeleton concealed within stone. Modern scans reveal that the pyramid was built in horizontal courses, stacked layer upon layer, like a colossal staircase rising toward the sky. Each level was slightly inset from the one below, creating a stepped internal core long before the smooth outer casing was added. These backing stones formed the pyramid's true strength. They distributed weight downward and outward, preventing collapse. At its heart lies the king's chamber, constructed from massive granite blocks, some weighing more than 60 tons. Above it, 5 hidden relieving chambers rise one above the other. Their purpose was simple, yet brilliant. They diverted the crushing weight of millions of tons of stone away from the chamber below. Without them, the ceiling would have shattered. But even now, the pyramid still holds secrets. In 2017, scientists using muon tomography, particles born from cosmic rays, detected a massive void hidden above the Grand Gallery.
a space unknown for more than 4,500 years. Not a natural crack, not random, but a deliberate architectural feature. Its purpose remains uncertain. It may be a structural void to reduce pressure. It may be part of an unfinished chamber, or something entirely unexpected. The pyramid is not simply filled with stone. It is filled with decisions. Every chamber, every corridor, every hidden space, a record of human problem-solving on a scale never seen before. This was not brute force. This was architecture. This was engineering. This was design.
Engineering hypotheses. The Great Pyramid did not emerge fully formed. It was the product of experimentation, trial, error, and correction. Its builders were solving problems no human had ever faced before. How do you stack millions of tons of stone without crushing what lies beneath? The answer can be seen in the pyramid's architecture. The grand gallery rises upward with corbelled walls, each layer projecting slightly inward. This design reduces pressure. It transfers weight away from the center. Instead of collapsing inward, the structure supports itself. The relieving chambers above the king's chamber serve the same purpose. They break the force of gravity. They redirect stress. They protect the most sacred space inside. Even the placement of chambers reflects engineering logic. They are not centered perfectly. They are positioned where structural stability allowed, not where symmetry demanded. This was not artistic compromise. This was engineering necessity. Modern computer simulations confirm what ancient builders learned through experience. The pyramid works because its weight flows downward in controlled paths, like water finding channels through rock. It is stable not because it is solid, but because it is intelligently designed. The pyramid was not built by magic. It was built by minds, human minds, observing, testing, improving, failing, and succeeding.
Inside the pyramid. To enter the Great Pyramid is to leave the world of sunlight behind. The air cools, the sounds of the desert vanish, and stone closes in on every side. This is not a monument meant to be admired only from outside. It is a machine of corridors and chambers designed for eternity. Deep beneath the pyramid lies the subterranean chamber, carved directly into the living bedrock, rough, unfinished, abandoned. Its uneven floor and incomplete walls suggest a plan that was changed. Perhaps it was the pyramid's original burial chamber. Or perhaps it served a symbolic purpose, connecting the king to the underworld, the realm of Osiris. Its silence raises more questions than answers. Higher up lies the so-called Queen's Chamber. Despite its name, no queen was ever buried here. No sarcophagus was found, no body. Its purpose remains uncertain. In its eastern wall stands a tall, narrow niche. Perhaps it held a statue of the king, a spiritual double, the Ka, where his soul could reside. Two narrow shafts extend from this chamber, not wide enough for a person, but aligned toward the stars, pathways for the king's spirit to ascend into the heavens. Then comes the most breathtaking space of all, the Grand Gallery, a vast ascending corridor nearly 47 meters long and over 8 meters high. Its walls rise in corbelled layers, each course stepping inward, stone upon stone, precision without mortar.
Its scale inspires awe. Its purpose still debated. Perhaps it served as a ramp for raising granite blocks. Perhaps it was a ceremonial passage, or both. At its summit lies the pyramid's heart, the king's chamber. Simple, severe, silent. Its walls are made of red granite from Aswan. Its ceiling formed from enormous slabs weighing up to 60 tons. Inside rests an empty granite sarcophagus, its lid long gone, its occupant vanished, whether robbed or never placed here at all. Above this chamber, hidden from sight, lie 5 relieving chambers, stacked one atop another. Their sole purpose? To protect this room from destruction. They absorb and redirect the immense weight above. A silent system of structural defense, unknown to the outside world for thousands of years, until modern explorers uncovered them. Even in death, the king was protected by engineering, not magic, but design.
Off-axis design. At first glance, the Great Pyramid appears perfectly symmetrical, balanced, precise, flawless. But inside, something unexpected appears. The chambers are not centered. They are shifted slightly toward the east. This was no accident. Ancient builders understood something fundamental. Weight does not behave perfectly. Stone settles. Pressure accumulates. By shifting the chambers slightly off-axis, engineers reduced the risk of catastrophic collapse. They positioned voids where stress would be safer, not where symmetry would be perfect. This was a compromise, but a brilliant one. Modern engineering confirms the wisdom of this decision. The pyramid's internal layout reflects structural logic, not ritual symbolism, not hidden codes, but practical necessity, survival. The Great Pyramid was designed not just to stand, but to endure for thousands of years, and it has. The Big Void. For more than 4,500 years, the interior of the Great Pyramid of Giza seemed fully explored. Every known passage mapped, every chamber documented, every secret revealed. Or so it seemed. In 2017, an international team under the Scan Pyramids mission made a discovery that stunned the world. Not with drills, not with excavation, but with particles from space, invisible messengers called muons. Born when cosmic rays strike Earth's atmosphere, muons constantly rain down upon the planet. They pass through stone, through mountains, even through pyramids, but not equally. Denser stone blocks more muons. Empty space allows more to pass through. By placing sensitive detectors inside the pyramid, scientists created a kind of X-ray, not of bones, but of architecture. What they found was astonishing, a vast hidden space, directly above the Grand Gallery, at least 30 meters long, nearly the length of a blue whale. It became known simply as the Big Void. It was not filled with treasure, not lined with gold, not a secret burial chamber. Instead, it appeared empty, silent, purposeful. Its existence suggested something else: engineering. The Big Void may have been designed to reduce weight, to protect the Grand Gallery below from collapse, to redistribute stress safely through the pyramid's core. A hidden structural buffer, invisible but essential.
It revealed something profound. The pyramid still had secrets left to tell, not secrets of myth, but secrets of design. The North Face Corridor. Then came another discovery, hidden in plain sight. On the pyramid's north face, near the original entrance, ancient builders had installed massive chevron stones, triangular blocks arranged to redirect weight, architectural shields. For decades they were admired, but never questioned, until subtle anomalies appeared in scan data. Again, non-invasive technology was used. Muon scans, infrared imaging, ultrasound. Each method confirmed the same thing. Behind the chevrons, there was something more. A corridor, unknown, unseen, untouched. In 2023, a tiny camera was inserted through a narrow gap. For the first time in 4,500 years, human eyes saw inside. The corridor stretched roughly 9 meters long, with a peaked ceiling, precisely constructed, deliberate. Its purpose remains uncertain. Perhaps it relieved pressure. Perhaps it protected the entrance below. Perhaps it was part of a construction ramp system, or something else entirely. Each discovery reshapes our understanding. The pyramid is not a static relic. It is an engineering puzzle, still being solved, stone by stone, void by void, corridor by corridor. Science and modern exploration. For thousands of years, the Great Pyramid of Giza has endured. It survived earthquakes, floods, wars, looters, and time itself. Its survival is a miracle of engineering and a responsibility. In the past, exploration often meant destruction. Walls were broken, passages forced open, artifacts removed, context lost forever. Today, science has changed its philosophy. The goal is no longer to conquer the pyramid, but to listen to it, without breaking it, without harming it, without leaving scars. Non-destructive testing allows researchers to peer inside solid stone, to see the invisible, while preserving the monument for future generations. Because the pyramid is not just an object of study, it is a world heritage, a survivor, and it must remain intact. Tools of discovery. Modern explorers do not carry chisels. They carry sensors. Each tool reveals a different layer of truth. Muon detectors use cosmic particles to see through stone. They map hidden voids, unknown chambers, invisible corridors. Ground-penetrating radar sends radio waves into the pyramid. Echoes bounce back, revealing changes in density, hidden features beneath the surface. Seismic testing listens to vibrations, sound waves moving through rock, detecting cracks, voids, structural weaknesses. Electrical resistivity measures how easily electricity moves through stone. Solid blocks resist differently than empty spaces. Together, these tools form a new kind of archaeology, one based not on excavation, but observation, not destruction, but understanding. Each scan adds a piece to the puzzle, a fragment of an ancient blueprint. Mystery versus uncertainty. There are still unanswered questions, hidden spaces not yet entered, design choices not fully understood, engineering decisions still debated.
But this is not mystery. It is uncertainty. And uncertainty is not ignorance. It is the frontier of knowledge. Every generation asks new questions. Every new technology reveals new answers. The pyramid has not changed, but our ability to understand it has. It is no longer a silent monument. It is a conversation between ancient engineers and modern science, between past and present. And perhaps future discoveries will reveal even more, not by breaking the pyramid open, but by seeing it clearly for the first time. Conservation and modern threats. For more than 4 millennia, the Great Pyramid of Giza has resisted time. But time is no longer its only adversary. Today, the threats are modern, invisible, relentless. Rising groundwater seeps upward from beneath the plateau, carrying dissolved salts into ancient stone. As water evaporates, salt crystals expand inside microscopic pores. Stone fractures from within. Pollution from nearby Cairo fills the air with sulfur and nitrogen compounds. Acidic particles settle onto limestone surfaces. The once smooth blocks slowly roughen, darken, decay. Vibrations from traffic, buses, and nearby construction send faint tremors through the plateau. Each vibration is small, but repeated thousands of times a day, they matter. Limestone weathers, mortar weakens, edges soften. The pyramid that once gleamed white beneath the desert sun now endures a different climate, an industrial one. The challenge is no longer building it, it is protecting it. Preservation science. Across Egypt and around the world, engineers and conservation scientists study the pyramid not as conquerors, but as guardians. They test the mechanical strength of limestone samples. How much pressure can weakened stone withstand? They examine salt crystallization under microscopes, watching tiny crystals grow like silent invaders. They analyze chemical decay, measuring how pollutants react with calcium carbonate. Understanding the enemy is the first defense. Yet conservation is not restoration. The goal is not to rebuild the pyramid into a modern replica, not to polish it, not to perfect it. The goal is survival. Stabilize what remains. Prevent further loss. Preserve authenticity. Every intervention must be minimal, reversible, careful. The pyramid must remain ancient, even as it is protected by modern science. Giza and the city. The Giza Plateau no longer stands isolated in desert silence. The city presses closer each year. Apartment blocks rise where dunes once rolled. Roads cut across ancient sightlines. Tourists arrive by the millions, cameras flashing, footsteps echoing in ancient corridors. Tourism sustains livelihoods. It funds conservation. It connects humanity to its past. But it also brings strain, wear, heat, humidity. Balancing heritage and modern life is now as critical as ancient engineering once was. Local communities depend on the plateau. Scholars depend on its preservation. Visitors seek wonder.
The future of Giza lies not in isolation, but in balance, an equilibrium between past and present, between stone and city, between eternity and everyday life. Legacy and meaning. After centuries of speculation, exploration, and debate, certain truths stand firm about the Great Pyramid of Giza. It was built as a royal tomb for Pharaoh Khufu, a monument to divine kingship, a sacred bridge between earth and sky. It was a religious structure designed to ensure the king's rebirth among the gods. Its chambers aligned with cosmic symbolism. Its form mirrored the primeval mound of creation. It was also a political statement, a declaration in stone that Egypt was unified, organized, powerful. Only a centralized state with vast resources could command such coordination, such labor, such vision. And it was built by human hands. Not slaves in chains, but skilled laborers, craftsmen, engineers. Archaeological evidence reveals workers' villages nearby, bakeries, barracks, medical care. Graffiti left by work crews proudly naming their teams. This was not myth, not magic, but organized human achievement. A civilization expressing itself in stone. Hidden costs of greatness. But greatness always carries a cost. Recent environmental studies examining sediment cores near Giza reveal something unexpected: traces of early industrial copper pollution. Microscopic particles embedded in ancient layers of soil. Evidence of large-scale tool production. Copper chisels dulled quickly against limestone. They required constant sharpening, constant replacement, thousands of tools, furnaces burning day and night, fuel consumed, ore mined, metal hammered into shape. The pyramid did not rise quietly. It reshaped its landscape, its economy, its environment. Even in antiquity, progress left traces, invisible at first, but preserved in the earth. The pyramid is not only a monument to vision, it is a monument to effort, to labor, to resource consumption, to the earliest form of industrial organization. Progress always leaves traces. Every great achievement alters the world around it. The Great Pyramid transformed stone into symbol, labor into legacy, material into meaning. But it also reminds us that every act of creation leaves marks behind, in soil, in air, in history. The ancient Egyptians understood permanence, but they also lived within consequence, and so do we. As the sun sets over Giza, the pyramid glows once more in gold, the same light that touched it 4,500 years ago. Shadows stretch across the plateau. The desert cools. Stars begin to emerge. The same stars that ancient architects once observed, aligning passages toward eternity. The Great Pyramid is not frozen in the past. It is studied, questioned, reinterpreted. Each generation sees it differently. Once a wonder, then a mystery, now an engineering masterpiece. Tomorrow, perhaps something more. Stone by stone, it still speaks, through structure, through science, through silence. And we are still learning how to listen.